Hello, welcome back to Satisfactory. As you can see by what's on the screen, we are addressing my old nemesis, the aluminum production line. This is going to be a new aluminum line, not related to the old one. What we're looking at here on the map is where I've decided to put it. And you can see my checklist up there. From the checklist, you see I need 600 bauxite for what I want to build. And it needs some local water, which we have arranged for. You'll notice on the map, if I can get my cursor onto it, the map is satisfactorycalculator.com. They have an interactive map. You can load a save into it. It doesn't upload your save to the website. It loads your save into the browser, and the website provides the code to the browser to do the rendering. So don't worry about uploading stuff. What you can see here is that I've got these nice little bauxite nodes. I've got a normal node and an impure node sitting here. In the normal node, I can overclock to 600 per minute. I'm going to be doing that. We also have what looks like water. Turns out these are puddles. They are not deep enough to extract water, and I committed to going here before I tried to put down a water extractor. Which is why, as you can see on the map up here, we have two water extractors sitting in the darker blue water on the map up here above the waterfall. And I've already laid out the beginnings of a little production area. We'll see more about that as I get back in. This is not my first take, by the way. I just spent half an hour recording the whole thing, doing all sorts of stuff without taking the interactive map off of OBS. So that's where we're starting. We've got water coming in from above. We have our bauxite nodes down below. We have a modest amount of power arriving from various directions. We're going to set up the aluminum, and we're going to do a little bit of tidying to make sure things are correct. Our goal on the output, if we look at our checklist, first of all, we have our refinery loop. So we're only going to be using 180 new water. However, sloppy alumina is going to require 600 water and 600 bauxite. Initially, this means we will be pulling water from both of our water pumps at full speed until we get going. Once we get going, the alumina solution goes into... Oh, that's twice as much alumina solution as I thought we had. Okay, I need to bear in mind as I'm doing this that my water and alumina solution are, well, water is a full Mark II pipe. Alumina solution is 2 Mark II pipes. Ooh, I'm glad I looked at the numbers. This is actually going to be a fairly big aluminum factory now that I think about it. We started out with modest requirements, and I kind of bumped things up a little bit. I'll show you where I did that. We need to take all of this and smelt it. We need to make some steel beams. I'm going to use the aluminum beam because we are going to have quite a lot of aluminum here. And we actually need less than one assembler each for these 4 things. Aluminum sheets, aluminum casing, heat sinks, and encased industrial beam. And just because it's easy to do the build that way, I said, well, let's do 3 assemblers on each. And that's what caused this to suddenly get big. And 10 miners mining bauxite, this is really 1 Mark III miner overclocked to 250%. So yeah, we are driving the size of this factory by overbuilding the aluminum sheets, casings, heat sinks, and industrial beams. But I think that's okay. We'll get this set up, and this will oversupply the base complex that we're building right now. We're building a big distributed base to do our phase 4 delivery. We're oversupplying it, but that means that this aluminum factory will continue to provide a lot of resources. And we can go to the old aluminum factory and scale it up as well. It is slightly differently organized. For instance, aluminum ingots are buried inside the build. So we have the ability to build sheets and casings, but we don't have the ability to turn out steel beams from there. If we do that, if we need more aluminum beams, what I would do is adjust this to have more constructors. So these two constructors are going to be in a 5x5 area, so we could lift them out, drop a blueprint in with a lot more constructors, possibly even stack it up if we need a huge number of steel beams. I do like the idea of beams coming out of my aluminum factory. I know it's probably not optimum, it's probably not good, but I like the idea. Anyway, so there's the checklist. Let's move that on my screen to a more convenient place. There's the map. I can turn off the map at this point. Oop. And here we are. There's the build area that I made. I have run some power. I basically ran across everything and ran power. We've got water from the top of the waterfall. We've got a nice view of the waterfall from our factory, which, the factory is going to block the view of the waterfall from everybody else, but yeah, get over it. This set of concrete here, I consider this to be sacrificial. It is there to act as a placeholder, to align it, to set up here. Here's where the initial pipe I set up goes. I might rerun pipes, who knows? And over here, you can see that water right there. I assumed I could put a water extractor on it, and you can't. Just to show you production, the water extractor. Got a little bit of power over here. We've run the power toward the bauxite, but not very close. See, there's just no place in there where a water extractor goes. Oops, I was exploring. So, I need to get my bauxite. Oh, there's still... I did a little bit of prototyping out here earlier. So what I want to do is have this guy on the proper, I don't need to worry about the grid. I just use the global grid. Foundations, so we're going to go to a concrete foundation, 2 meters high. Let's make sure, I think this is the, yes, he is the normal. Going to bring you in here. I'm going to just put you on corner. Production, miner Mark III. Going to face you to the right so you can make a nice right angle turn and go up. I need you to be 600 per minute. You can tell I've been doing a lot of experimentation around here. And I tore it all down because it was all horrible and awful. And I did it all behind a CIM display, so it didn't even get recorded. So there we go. There's our bauxite. And he needs to get up there. He needs to come together with the water. Boop-a-doo. So I'm going to put in the first 2 refinery blocks. So I've got fresh water coming in here. I feel more comfortable about routing bauxite randomly. So blueprints. Let's see, unconfigured groupings, refinery cluster here. I'm aligning this with the power floor blueprint. Rotate it so that the white arrow is towards me because I always set up my blueprints with the notional input side of the blueprint being the white arrow. I'm just going to stamp this down twice. This is just a bunch of unconfigured refineries all connected up completely in parallel with splitters for the input and mergers for the output. So this guy, he is making sloppy alumina. Let me reduce the size on my checklist a bit. There. Now we want to run the sloppy alumina at 75%. If I do a mergeless solution, the overclocking for the one on fresh water is different from the overclocking of the three that are not on fresh water. But that's all that changes, and you end up changing your water loops. So this guy would become fresh water, and we would sever this here, and these guys would just connect across. Make sure these guys are set, so 75% across. Oops. There. 75% sloppy alumina. This has solid input of bauxite on this, and it has input of water on that. So this water needs to hook up to that. You are going to come down here. Why is this ticking down below? Again, this whole aisle here is sacrificial for alignment purposes. We may keep some of it. I will have to think about how I want to have my pipes represented. This guy is to the left of here. We're going to bring him to here. There. And we now have fresh water coming in. And this fresh water actually needs to come in from above. We'll rework that later. In this area here, we will have the prioritized input mixer. That is really just to placeholder things. There. And the bauxite comes from here. I think what I'm going to do is I will zoop these out. There. We still have to worry about power coming down this guy, but that's easy enough. I'm going to think about the next set of power. I'm going to bring this out to, that looks about level. Is that right? That low? Actually, let's bring it down to here. One, two, three, four, five. This would be our one past the 5. So if we put a 5 in here, it would be these guys, and then we would have a 1 going this way. I always think in terms of what if I want to include another set of these guys. I probably will not expand this, but let's leave the organization set up for it. 1, 2, 3, 4, 5. Here. 3, 4, 5. So here. And this needs to get over to that guy. He needs to come over and up here somewhere. So what I'm going to do is bring him out and make him turn and come up. And I'll bring him to this lane. Go to straight mode to get this nice and 90-degree angled. And now we have this bauxite line coming up here, which we can now route in a future-proof way back towards our bauxite. So I'm going to put it on, oh, how about this lane? So not the center, but the next one over. Now this is going to go down center here. There we go. So now in theory, these guys should be able to crank up right up until they run out of alumina solution. And they need power. And for some reason, this is not connected up. Oh, that's confusing. Okay, so we have a power confusion. This power is coming in here and doing this guy. We also have some old power connections. No, that's to that way. What is this? Ah. That's why we weren't getting power. And now we can take power up here and up here. And there we go. These will happily fill up their alumina solution output here. So the one thing I haven't done, which is kind of important, is we do need to paint these real quick. So you are water. When we start dealing with fluid loops, getting your fluids mixed up is unfortunate and hard to fix if you get it wrong. Well, not that hard to fix, you can flush it, but it's ugly to fix because I tend to have fluid pipes do all sorts of weird and wonderful things. So these guys are the electrode aluminum scrap. This is a alternate recipe that I actually just picked out. This uses petroleum coke. Doesn't use a whole lot of it. 60 coke per 180 aluminum solution. But that does mean we need to import, what, 240 petroleum coke if we're cranking this up all the way. That's beyond the scope of this initial factory, but that does mean that we may need multiple drone ports pulling the coke in. Or I might need to find a local supply of oil. No, denied. No local supply of oil for us. There's some oil down here. Yeah, in theory, we could take over that crude oil and start building petroleum coke out of that and running it up. So when time comes to really scale this up, we can get a better local supply of coke. But we got coke input, and this output is from this guy. The other thing with the fluid loop, what we want is we want this fluid to come in from below and the fresh water to come in from above. And that's going to require a vertically oriented thingy. I have had more trouble. I'm going to see if I can get that in place. We're going to start moving fluids between the back and the front here, so I want to get my vertical correct. I think it's 2 offset from where we want the vertical. So if I want the vertical to be, say, here, I'll tell you what, bring it out to there. I'm going to trim that off, stack that guy on the end and roll it vertical. So now our real water comes in, our fresh water comes in from the top. I am going to bring it in at that level. So we are once again going to move our water. So from here we go back to here. And from here, boom, boom, like that. I'm going to bring it all the way out to here. And then we come down and right to there. Which means that this layer, whoops, he doesn't go away, he does. And this layer of concrete goes away. I'm going to leave that there for the moment because I still don't have confidence this is correct. And in fact, look at that. We could go 1 meter lower to be great. I want to go over and down vertically, and it's not doing that. It's still not doing it. Okay, so we have to force the issue by coming in like this. Now, this all happened in clean pipeline, so where do I want that will give us these little pulsating knobby things that show us that we're actually moving stuff. So we'll leave the sport in until we're absolutely sure this is correct. Now this guy goes down and back. And again, horizontal to vertical, it's almost right. Well, let's see. If I carve this off, and I run this a long way, so it's going to be here, 1, 2. And that is not right. See how that's sloped? If we run it the other way, horizontal to vertical, and again, it's sloped wrong. So instead we come over to here, and I start from here. Come on. Hologram it, and I'm going to nudge it around until it looks like I got it right the first time. There we go. And this and that connect. See, now that worked just fine. So at the moment, what's happening is that the fresh water is coming in here and it's backfilling into the outputs. And we want to absolutely be sure that when these guys produce, they produce into their local buckets, and that as this consumes, it drains the local buckets here. And I don't care what it does in the pipeline in between. Okay, so our output, we are not accumulating output. I was a little worried that we would actually be backfilling into our output buckets. Oh, I need to get rid of all that crap, don't I? I need to put down a sink and drain some stuff out. So this is all water. There we go. If I need to go mergeless again, we'll just route the water back into the first one and we're done, and chop it off. These guys take in alumina solution and petroleum coke. Well, this is alumina solution. It's white. And we get the aluminum solution out of these guys. So I'm going to mark these as white. And this is the alumina solution. And you'll notice now it's really clear where we have white pipes and blue pipes, and I need to make sure that this doesn't do what it's about to do. There. So this needs to go over there. So I'm going to bring it down the middle. The easy way for me to do that is to just do these two guys to the middle, backed off by 2, and connect them up. And there's our alumina solution. So aluminum solution and aluminum scrap are both kind of white. I will color these refineries the same. Yeah, it'll work. So I can glance at this and see what's going on. We want to have some valves in here so I can see who's got their actual contents. The other thing I think I'm going to need is some way to flush the recycled water area, or at least make some room in it. So in order to facilitate recovery from disasters, I'm going to put a little buffer out here. Wait a minute. Hold that thought. Putting a buffer in may change the fluid dynamics. Let's give the simple solution like this. Let's give it its chance to rock. Without crufting it up with, oh, let me put a buffer in so I can flush it, yada, yada. Can I do a flush on the, can I just, oh, I can actually flush from the pipeline. I don't need the buffer anyway. If we had a lot of variability, I've used this in other builds, putting in an industrial container is a nice way to capture overflow and then be able to flush it away if it isn't dissipated. But like I said, simplest solution first. Now, before we can crank this up, I do need my petroleum coke, which means I need to put in my, I'm going to need 2 drone ports, because this is an active drone port to fetch the coke. So I also need an active drone port that fetches the batteries, not the batteries, excuse me, the fuel for the drones. So 2 drone ports. What I'm going to do, I can always relocate the drone ports, but what I can do is start out with blueprints, drone stand here and here. They're kind of off the beaten path when it comes to power, so I'll have to run power out to them. So let's see, my best way to get power into these guys would be, see, there's a problem. Oh, and this has been building out of the depot and destroying into inventory. That's part of what my issue is here. Okay, so now my need for a discarding machine, a sink, is critical. Builder. Special awesome sink. And we need a industrial storage because I have a lot of stuff I want to sink. Get you some power. What can I sink here? Leaves. Come on, leaves, wood, quartz, terbium and wire, plastic and rubber, bauxite. This is all for piping. We've got plenty of it. The reason why we have so many of it in our inventory is because we keep building and getting things back. All of this, in fact, can just go. Now we have a small supply of miners in the dimensional depot. We don't want to delete them. Those guys I keep in the dimensional depot until I'm ready to process them. There, we're good. Back to getting power to our drone ports. So what I'm going to do here is I'm going to run my power out to the middle of the bottom plate. And now I can go to any one of these. And actually, it could even go to the middle there if I wanted to unpack this and show it up. Well, unpack it and I got it in the wrong place anyway. Let's try this again. At that location, we're going to put in a drone stand, and this time I'm going to look at it and verify it's in the right place. There we go. And I'm thinking that coming up through the middle is nice but cheesy. I bring it to here. That's acceptable. This tree, unfortunately, has to go. So same thing here. I'm going to bring this over. Doesn't really matter where. If I put a power floor in here, I can rework my electricity. So we now have electrical power up to below these. I need to bring in the drone ports. And this guy needs to be sending its output over this direction. So somewhere in this line is where his output is. Now, our actual stuff Turn off resources. I believe our coke comes from one of these two. Rubber supply. Yeah, it comes from over there. So it's going to come from the north. So we'll put our drone port. Oh, we need to have the drone port output over there. So let's see. If I put the drone port facing this way, its output is on the right. Let's just toss it right down there. Now, I've always liked the look of this sticking out tab and having it not be over foundation. Kind of cool. There's a natural stacking when you do tiers of drone ports where each one backs off so that this tab sticks out over the top of the previous one. Kind of cool. So, power. Coming in along this line somewhere. And along this line. So that guy and that guy here maybe? Close enough. So we need to get power from you. Take you right up to there and right across to there. And this is coke for aluminum. Now, next to it, we have our drone fuel. Comes from basically the same place. This is drone fuel for aluminum. I believe you're just in the same place here. Yep. So this guy will be fetching fuel. Let's get him going. Let's see. I want 2 packages of turbo fuel to start with. And you get 1. And what I'm going to do is I'm going to load, oh, let's get this guy actually moving, this port. So we've got drone fuel north, south, east, west. We're going to go fetch from drone fuel south. I think there's other people on drone fuel south. Yeah, that's okay. Deuterium and aluminum can share a drone port for fuel. So what I'm going to do is I'm going to shove this in my incoming, and now we're going to use that to set this up. I want you to come down here and over here like that. I believe this is our only active port, but I could be wrong. If I'm wrong, I will rework it. There. If I did this right, the fuel should flow. It should fill the fuel here. And now I can put in a drone here. This is coke for aluminum. Petroleum coke supply. And actually, let's... There we go. So we will start getting fuel in over here. We'll start getting petroleum coke in over here, and now we can route this output. I want to put it on a defined lane rather than as close as possible. And we're going to there. I'm going to bring this dead centered like that. If I did this right, we should soon see some petroleum coke coming in here. We are making electrode aluminum scrap. Let's make sure all 4 machines are configured. Because they're soaking up alumina solution immediately. Now, if what I suspect is true, and if this, I am not actually a true believer in the junctions always take from below. I have some evidence from the previous aluminum factory that if everybody is completely full and has enough head lift, it merges half and half. So it's just a suspicion. It's just a suspicion. But if it's true, then this means that we will be taking too much fresh water, and these guys will bottleneck very quickly, and we'll get a deadlock within a few minutes. And if that happens, we will decide then what strategy we're going to take. So he is back with our first load of drone fuel. Let's see, 30 per trip. And it's almost 4 minutes per trip. Almost a minute at that time is the animations for landing and taking off. So this is still fairly fast. 207 items per minute. So if the other guy is taking, well, this guy's taking 8 fuel per minute. If the other guy's taking another 8, 10, 20 fuel per minute, that's like dropping the bucket. So we're good. I thought I had gotten rid of most of the stinky gas up there. Oh well, it's kind of pretty the way they do it. You know, if you ignore the fact that it's stinky. And here comes our other drone. I wish I could rename the drones. How come this guy got renamed? Drone base source, drone base sync, drone. How the heck do I rename a drone? Do they get their name set when you add them to the drone port? Didn't notice it's got little antennas. Somebody was looking at moth pictures when they built these drones. Kind of cool. So now we should get the coke out. I've been kind of wasting time here waiting for it. What I'm going to do for the moment because this is a big multi-level factory that does many different things. I'm going to run that into a, I'm just going to, this is strictly temporary, industrial storage, and a awesome sink. Actually, no, let's not even do the industrial storage. Let's just do it right into the sink. And you need some power from somewhere. Doesn't matter where. So what I'm trying to do here is keep these guys happy so they will continue to run. And his water is draining fairly well. So these guys are producing, let's see, 600 water total. They're producing 420. So between 2/3 and 3/4 of the water consumed. So I would expect these to spend 3/4 of their time, 2/3 to 3/4 of their time draining. If they keep accumulating water, then the merger is not working as advertised. And what are we seeing there? What we're seeing there is it is accumulating water. But they're drained all the way. So what could be causing that kind of back and forth, that kind of accumulation and going down? Well, these guys trigger every 4 seconds, they're adding 7. And there's 4 of them. That doesn't mean every second we get some. It means every 4 seconds we get 4 bursts, which may be weirdly offset from each other. This guy's also every 4 seconds we're drawing 10. So the timing is the same. That's interesting. The other times I've looked at this kind of a layout, not with these recipes, the timing has been different, so it's been different periods. This may work. If these guys are consistently getting drained down to 0, there we went idle. So this guy did not get its water drained in time. So one thing I can do to experiment is I can put in a pump that aggressively pulls the water out of here and pushes it in here with high head lift. So if we were doing pressure, it would do the pressurization thing. So what I'm going to do is I'm going to drop down into here. I'm going to pick that guy out. And this means we're going to stop. I'm going to put in a pipeline Mark II right there. Oh, and wisdom of the net is that pumps with no power reset head lift. That's also something that I want to actually prove, because I think, as before, I think I have experimental evidence that in 1.0 they leave the head lift unchanged if they're unpowered. So this is going to keep this pipeline absolutely full, even when this guy starts getting low. This guy on the end is the one that has the most problem. Let's dump the network here. Did I dump all the way back to my pumps? I did. Oh, this is going to be a while before this gets working again. Frick. I meant to just dump up to the pump. Okay, so if you're going to dump that, you want to disconnect yourself and drain the stuff that you disconnected. Also, this means that my pump here is going to backflow into here quite significantly. We'll just have to wait for all of this to be completely full. But let's get these painted while I'm waiting. This pump was originally here because I was going to go up and around. And I didn't want to have to worry about the level. Right now, it's just there. Now, if these guys are if we're actually using all that water, they won't fill up. Oh, I thought I'd overclocked everybody. Okay, let's get these guys overclocked so that we are sure that we are going to fill everything up. We can put them back to normal because we only need 180 out of it. But running them this high initially makes it so that we can get our water system completely full and pressurized. Filling. Occasional bump. So up here we are producing a total of 600 water per minute. So if we didn't use any recycled water at all, these pumps would be running 100%. So how much ever these don't run is the recycled water that we use. And what I want to show is that we are using more than 50% of our requirement comes from recycled. Now, unfortunately, I think the 79% is going to be our long-term average. It's going to settle in eventually. It's going to take a while, and we'll need to look at them both. See, if our total is 600, we want to do 420, 600 minus 420 is how much we get. So 30%. So if these guys settle down to 30% efficiency, okay, so if this number settles in at 30%, then we have a proper mix of our recycled water. Anything over that, that's only true if everything is running. So given that we have to have everything running anyway, and what else did I forget? You know what I forgot? I forgot that the alumina was 2 pipes. So in order to make this work without totally messing things up, what I'm going to do is I'm going to downclock everybody to half, and we're going to get it working downclocked to half of what it should be. So you are going to be target production rate 90. And you are target production rate of 150. Sorry, I completely messed up on the fact that we were bottlenecking on the alumina. Yeah, so these guys should have been filling up their alumina solution Probably should have checked that. I can go back and look at it in the footage. But 90 per minute, 180, no, 90 times 8. We were running 720. So yeah, we should have been building up alumina in these guys, slowing them down. So yeah, I can't do that calculation for the pumps because it depends on everybody running at 100%. And we all know that if I assume everybody's running at 100%, I can prove everybody's running at 100%. So yeah. These guys are running at their down clock, so we're going to get it running stable with a down clock first. Oh, and aluminum scrap. Is there anything in this whole thing that is going to limit us once we have merged? Mark 5, Mark 5. Okay, how about lifters? These are Mark 4. Mark 4 lifters should be good, but let's make them Mark 5s. Just to be consistent. I'm just going to do that all over the place. This guy doesn't have any solid output. Spending a little time doing this will let everything come to a steady state. Let's just do everything in Mark 5. There. And this guy. So these seem to have no problem draining their water for now. I need to set these up so that we get two water pipes going, two alumina pipes going. I think the best way for me to do that in an organized way is to do something I don't often do. I am going to deploy the stackable pipelines. And I'm going to put this in the middle here. Well, wait a minute. I have to get down to that guy. So let's, can I do that? I can do that. There. We get the top run first. These guys have some stuff built up. If we go horizontal or vertical. Okay, it doesn't actually do a horizontal to vertical on these guys. There. So if we went to the non-merge, what would happen would be the top pipeline would get the alumina from the first machine, and that would start these two machines on the end going with the recycled water, and then we get everybody else doing the recycling, and then we get all four machines going. So it still would work. It would just take a little bit longer to crank up. Okay, so that seems to be working. Let's see, we're not building up any water in these guys, so let's put ourselves back to 100% on these. And back to, 180 per minute on these guys. So now we're back up to full speed. So this is the simplest solution, augmented with a single pump in the recycled water line. We saw that the one on the end was the one that had problems, so we're going to watch this. I'm going to take a few moments to go get some soda or something. I will let this run in the recording so we can later go back and examine the recording and find out what went wrong if things go wrong. I'm thinking this might be, I don't know, maybe I should give it 10 minutes. How about that? What do you think, 10 minutes? Yeah, 10 minutes. I will see you then. Oh, wait a minute. Electrode aluminum scrap is turning out 300 per machine. We need to have 2 lines of output for this guy, not just one. Okay, well, we'll put 1 sink there. I want to do this really quick before we bottleneck on the scrap output, which is something I didn't expect to be saying. It means we get rid of this merger. And here's one output. Here's the other output. Going to have to rework that a little bit. And you need some power from somewhere, anywhere, doesn't matter where. Get you back up and running before we bottleneck. Oh, I don't think we hit 500. Tell you what, let's pretend it never actually happened. There. Now look at this bauxite line. We are consuming the bauxite as fast as we can mine it, and that is clearly dealing with that at 100%. So if nothing else, that's our number one indication things are working well, is if that continues to do that for us. And once again, I believe I have failed to reconfigure this. Supercomputers are kind of expensive to build. There. So take from inventory before depot. Good. So if I were to let this just run for several hours, well, we can turn our picture back on here, as I actually didn't get as far as making coffee before I realized what was going on with that scrap. So if I let this run for 6 hours and I came back and this line was still looking like this, nothing else here matters, because all of this bauxite would be getting turned into aluminum scrap. And anything else here is just window dressing. So the 10-minute timer I set is still running. And my water's, so yeah, I'm thinking that the ultra simple thing, I don't know, I still can't prove that the VIP principle works, but when they wrote the document and they did the pipeline manual, they had a lot of experimental evidence saying it worked. I had a little bit saying it doesn't seem right, and in this case, this is working for me. So I'm not going to go all out and say it doesn't work. What I am going to say is, in this configuration, it works just fine. And I have to explain why in my blender configuration, where the recycled water was all but 1/6 of the input, why I still need to explain why it failed. It could be that when I go back to my main, when I go back to my original aluminum factory, I will rework it with this. Let's get so we can see the whole thing. So here's our simple junction. I'm going to go into photograph mode here. Oh, come on, can we get rid of the hands? Thank you. So here's our recycled water coming in from the right. I have a pump. So all I've added is the pump to the simplest possible layout. And it comes into a junction from below. The fresh water comes into the junction from above. And this appears to be working just fine. And what did I figure? Our fresh water is 30% of our total. So if this were trying to take 1/3 from each one and getting 2/3 from the bottom, we would not be getting this behavior. So it is, in fact, taking 70% from the bottom and 30% from the top. And with that in mind, I'm going to go back up to the pumps because the timer is still running. We still want to have our nice fare at the 10-minute mark, even though it's not really fair anymore because I kind of jiggered it around during at the 5-minute mark. So we are going to recover our shards. We only need 180 per minute from up here. So in fact, I'm going to bring these guys back to just barely big enough. If this guy ran at full power all the time, this would pretty much guarantee that it works, this and some buffers, even without the VIP junction. So I think we have several levels of safety built in. If he slows down, the fact that this is known to work should save us. Now, the downside of the VIP junction in the standard formulation, this is where you have a pump at level on each of your inputs. Well, yeah, I believe it's at each of the inputs, and one of them goes up and comes down from above, and the VIP says it's going to take the level one before the one up above. Hold on, maybe I can bring this up. Let's see if I can find it. Pipeline manual.pdf. Oh, let's turn on the editor. So we are looking for the VIP junction. By the way, if you haven't read this document, go find it and read it. Basically, search for satisfactory pipeline manual. There should be a billion hits out there. So, in VIP junctions, we've got two inputs here on the level. They both go through pumps. One goes up a little bit and comes back down. The other one goes straight through. And the VIP says that we will prioritize taking from here as long as there is, you know what? I think maybe my problem has been that I've been doing VIP junctions without necessarily setting up pumps on both of the inputs. That could be it. That could be it. That definitely could be it. Anyway, so this says that this guy is going to get through, all of his input's going to flow through, and then anything that you want on the output that he couldn't satisfy, you're going to get from the other one. And you can do the same thing with variable output. This one's actually simpler. What happens is, if this guy sucks out a whole bunch of output, the water level drops. I've seen that happen. And of course, if the water level doesn't come up to this guy, oh, there's our 10-minute timer done. If the water level doesn't come up to there, it's not going to go out there. So this is kind of an obvious one. This one isn't so obvious, and I believe it is taking advantage of a special case in the fluid dynamics code inside Satisfactory. This still holds, I think. I'm coming around to that because of what we saw here, what we saw today. I would say that the VIP is probably a good thing to just assume it's still working. Anyway, when we go back and revisit blenders, I will prove it one way or the other. Anyway, these are running clean at full rate. Again, I am glancing at it, and I can look at it in the recording later on to confirm everything is beautiful. And we have 2 lines of alumina coming out. Each one has 600 scrap on it. And let us rework this to be the way I want it now. So I want to come out to the next 2 landings. let's update our checklist here real quick so we can see what we're doing. We have our refineries, making scrap and alumina, and we have pumping water. Oh, let's make this into a nested checklist. All you guys get indented a little bit and you become dash like that. Refinery's done. Resources are done. Net imports and exports we'll be checking later, but actually let's see. I have a range for petroleum coke to come in. Concrete, rubber, steel. Hold on. Oh, right. Yeah, special case for this one. If everybody's cranked up, the people that are that need steel beams are going to slow down. So what I'm going to do is I'm going to say prioritize the export of steel beams. Oops. No, we're just going, okay. Aluminum ingots. Export casing, sheet, sink, beam, and ingots. So we do export some ingots. So I need to arrange for an export of ingots. And I need to have that prioritized. So we got our 600 aluminum ingots. We first export. Second, we build aluminum beams out of it. Is that the way I want to do it? Fill the beams, then fill the sheets, then fill the casing, so we just prioritize it straight on through. I think we're just going to prioritize it straight on through. So, and because of the quantities are so strange, we could actually just use normal splitters, because if we're sending half of our 600 to that 45, it's just going to be whatever it wants. So as long as we build them in that order, normal splitters will be good enough. So, aluminum scrap, the only thing we do with aluminum scrap is turning it into aluminum ingots. So we can collapse those. And I can reduce the size of this. And that's all we want to do, is build aluminum ingots. And we're going to merge all of our aluminum ingots together. And one is going to be here, and one's going to be over there. So these right-hand two guys, what I'm going to do, so I'm going to have them merge and go out to the right. No, I'm not, because this is in the way. If I bring them down pointed towards each other, I can put a merger on here coming out to the front and have this guy stripe off that way. There we go. And these guys are already properly set up for this guy coming out this way. So we have two sources of scrap available here. We are now going to use smelters. Lots and lots of smelters. There's actually 20 at 100% or 16 at that. They're smelters, they're small. Do I have a 10 smelter blueprint? If I don't, I'm going to build one real quick. I don't have any 5x5 smelter blueprints, so let's build one. And yes, I think we are back to the long recordings for now. So for the smelters, I'm going to want a normal underfloor. I'm going to want to bring my inputs up through the middle, split them out to the smelters, bring the outputs together, and merge them together out the back. Now, I could have two outputs that I merge. What I will do is I'll provide the merger at the back. I'll provide this. I'll provide the splitter chain in the middle. Oh, what if I start out by splitting it, and then we go to separate splitters on the outside? Let's see. We've got 5 by 5. This is a lot of space. Now, I am not going to try to do a 10-to-1 balanced merger or even a 5-to-1 balanced merger, balanced splitter. It's just, too much sugar for a nickel. We're going to set these up as a normal, everyday manifold. So if I put it here, that means I'm bringing it down here, which means the merger is on center on this. If I bring it to here, I can probably sneak this guy over one. Oops, I should have put him on my hotbar there. Does that look okay first? I believe with the smelter tucking it all the way in is a good look. The answer is no, it's a crappy look because we've got, I think that's not centered. Well, I guess it is. Something about it feels off. Anyway, we can't use that because it's got that big old waffle cone pointing out like that. Yeah, I did have it the right way. Well, what if I put it over here? That still has our mergers for the manifold coming down the middle of the thing. And I want to put it, can I put it like that? It's still got the damn bellows like there. Okay. That's going to have to do. Now for the up, I would like to put it in there again so we can have the manifold coming down the middle. We've got plenty of space here, so I don't need to bring it too tight. But I want to work these as compact as I can reasonably make them. And in fact, I can make this a slice just like that. Now, something to assure that we are aligned appropriately, I am going to start with painted beams across there, and we want this guy to be from here to here. And I think painted beams like that are going to prevent this from being put down. Snark. Can I put one above it? Why are you not coming across? There. And that forces our bounding box. So we're going to do a splitter coming from that direction. Actually, this is a splitter in the middle. And a merger. Oops. Yeah, merger. So if we could put 5 of those across and then mirror it over here. Easy way to mirror it is to rotate it and then just reverse the belts and splitters and such. So the alternative is we come in and it loops around, and we go out and it loops around. So we get in here and out there. That's not actually too bad. I may do that. I think I will. So I'm going to save this as new blueprint. We're going to put you dead center here, like that. I'm in build mode blueprint, so I should be able to clip you on there and you on there. Now I'm going to connect all these together, and then I'm going to rotate the bigger blueprint. You see what I did? Yeah. Try that again. Clear Blueprint Designer. Blueprint. Grab this. Put the first one down in the appropriate place. Yeah, here. It looked wrong because it is wrong. Why could I not bring it out to the right? What is it about those painted things? Blueprint, okay. Can I do this with walls somehow? Okay, I've had it. Load blueprint. Try this again. He's properly aligned in his proper place, and the beams are not doing the right thing for getting our extent. So walls, basic wall. That's going to be too wide, so what we're going to do is going to use a basic wall through the middle to set that extent. We'll just have to line them up horizontally the way we like them. Save blueprint. Clear blueprint designer. So we want, so I'm not going to line it up on blueprint. I'm going to manually place them at the distance where I want them. Now I think we can probably, yeah, we could set this up closer, or could we? I am not sure that any closer actually works. Okay, so there's the first 5. Save that as new blueprint. In fact, I think I can just put the new blueprint down, rotated. There we go. Now, if I didn't rotate it, I could do the split on the front and the merge on the back. Let's do that. Yeah. I am changing my mind again. This leaves us with a whole bunch of room down the middle, which makes me wonder, if I was really clever, could I fit 3 of them across and more than 5 of them that way? Somebody else will probably figure out a maximum packing of smelters in a 5x5x5. Not our goal for today. So, merger of the outputs. Splitter of the inputs. So these guys should be from left to right. That's a splitter, so that's the inputs. So we just do that. And these are our mergers. They are the outputs. There we go. And if I want to peel just one of these out, I can always, after I place them, erase that. So, wall bits. Those are gone. So now what we have left is power and the floor. So put the floor in first. How you stripe the floor is really very arbitrary. Okay, number 1 bit of power is the Mark II wall outlets underneath the main floor. get those connected up while I dither in my mind as to whether I am going to take all the power from all the smelters down below, which is kind of awkward, or if I'm just going to do it above. And I think what I'm going to do is I'm just going to gather them above. So we're going to go to a Mark II power pole here, and a Mark II power pole here. And yeah, one of these is going to be better looking than the other. And to get it down to the bottom, we grab a wall outlet and we put it in place there. This wall outlet's in the wrong place. We can fix it along with doing these guys properly. There we go. And sometimes I put power poles on the corners. I don't think I'm going to do it for this one. In practice, I am needing the power poles in the corners a lot less than I expected. Oh, I didn't see there's a purple guy down there. So this is 10 smelters. It has 2 rows of 5 with input. Each row using boom, there we go. Save blueprint, BB smelters. We have one more thing I want to do here. I want to actually configure these smelters to do the aluminum ingots. So these are turning 60 by 10, 600 scrap into 300 ingots. We're going to build it twice, so that will match our checklist item in the upper left. Whoops. 600 per minute aluminum scrap into 300 per minute. Aluminum ingot, there we go. And now clear this out and get rid of it. Clear blueprint designer. Take all. Delete you. And now we need to put down 2 copies. Let's get our power going. and our input. I think I like the idea of using 2 foundations wide for my interstitial areas here. It also means that if I come back and button these up into a better building before they get deleted and rebuilt completely, we'll have a little more room to spend working on a textured facade and walls and such. So to verify this is working, you know what we're going to do? We're going to sink it all. I need power from somewhere. There we go. We've been sinking a lot of stuff. Do we have ticket? Oh my goodness, 40 tickets. Oh, that's right. I think we turned on a whole bunch of sinks elsewhere. So our base is doing a whole bunch of things. That should be visible in our power usage. Okay, so currently we are over 30 gigawatts of power available. We are consuming at a nice steady 12 and 13. This tells me that we've probably turned on a whole bunch of stuff. Let's take a look at our priority power switches. Yeah, everything's turned on. So in fact, we've got our sinks turned on at the old aluminum factory, at the steel factory, and rubber and plastic. So all of these factories are now running at full tilt. So with these guys syncing their outputs, everything should stabilize back to all machines running with 100%. So these machines built up a bunch of aluminum scrap, which we have to drain out. And these guys will be accepting all that aluminum scrap into their input buffers. So I think we can just hover here until these 2 belts are no longer completely filled. And now I really am going to go try to get some coffee, and I will be here. So apparently, the aluminum scrap machines have a whole lot of aluminum sitting in their buffers. I suppose I could just empty it out manually, and we could see what it settles out at when it's not that way. This will also get us a read on just how much coal we're using, petroleum coke. We don't need any of you. I'm going to dump the rest of this junk. There. Oh, and this is the playthrough where I will eventually be building up enough tickets to finally buy my golden nut, which I've never done. Also, during early access, I never completed Phase 4. Of course, its requirements for Phase 4 were different, but I didn't want to see the end of phase 4 until I was playing it for real in 1.0. And they've changed enough stuff that I probably should have just gone ahead and done it. So here we are. So we can see that it bursts it in, and we also can see that these guys are accepting it at rate, but they're not accepting it constantly, except in bursts. And all their input, well, not all their input buffers, their input buffers are filling. Oh, that's right. This is a, yeah, okay. So in theory, once these guys at the end are constantly getting enough scrap to run, we should be draining the line as fast as it fills it. And the percentages down at the end are going to be low until it's been running for a while. The other thing I can do is let the output back up, and then put the sinks on and harvest the outputs, and then see how things go. So we start up with a filled manifold, but I think actually we're good here. And again, notice that the water is not building up. So yay for the simple solution plus pump. I'll take it. I like being wrong. VIP junction's working just, well, this isn't even a VIP junction, but the principle behind the VIP junction is working just fine here. VIP would have me bringing it in level. I needed to bring it in from the top anyway, so then the bottom was perfectly cromulent. So this would have been slightly simplified in terms of the piping layout if I had reversed these guys, but that would have meant that our input came in from the back and our output was here. The other thing you can do is have this proceeding left to right. So, well, excuse me, have the water, all the water loops in the middle. Now that puts your aluminum around the back. We really do need to have water and aluminum on front and back. So yeah, turning this 180, it would have been awkward getting our output out or getting our input in. One or the other gets awkward. I figure it's the piping that's awkward. Let's just let the pipes do it. The other way to do it is to lay them out. Water here, aluminum, the other processors, and then you take its recycled water and you very explicitly bring the recycled water back and you deal with it. Given some of the things people do to deal with recycled water get pretty complicated, and that is definitely me. Having the recycled water output nowhere near the water input and having an explicit area to do the merge is probably not bad. But again, look at how simple that is. And it just keeps working. Okay. So that's our smelters. So we need to merge the aluminum ingots together. We need to provide some ingots to a passive drone port. And then ingots need to go kind of down the middle of the factory so they're available to everybody. And I think I'm going to make this like the previous one I did, and I will have assemblers to the left and right of a central area, and then I will run my ingredients down the middle on a vertical bus. So my V bus is going to run right down this seam. And in fact, let's start it off by putting mergers in. I don't know how many I'm going to need. Let's commit to having at least 3, and there's our first level. And our first pull out of this will be to send one out to a drone port. I don't want to do this. How do I want to do this? Could I put the drone port right over the top? No, I don't want to do that. If I put the splitter here, well, I don't want to base the drone port on any of these four. That would really cruft things up. We already have drone ports out on this line. So what I will do, 1, 2, 3, 4, 5. So here's the outer border. I could put 2 drone ports with aluminum ingots on them if I thought I was going to use ingots in a lot of other places. That would also mean that other factories could grab aluminum ingots and turn them into steel beams if they needed it, or into other aluminum things. What can we do with aluminum ingots? Used in sheets, casings. I believe we have sheets and casings being provided. Fuel tanks. Oh, this is what we're actually sending it out for. We have a nitrogen loop that requires ingots to make fluid tanks. Apparently it's used in a bunch of things. So what I'm going to do is I'm going to go out here and I'm going to have a drone port base right there. And another drone port base here. Because aluminum ingots, I think, might be useful. Oh, we need to put these in place. BB aluminum ingot smelting is in... we need a new group. Add subcategory. Yeah, let's just put them all together in one group. I was going to split them out by what kind of factory they were. Put them up there, ingot smelting. We'll just list them out like that, and I can move things up from other places as well. Configured groupings is not going to accept a lot of these. 4 refineries, 8 constructors making silica. Yeah. All these that I put in small bases are all the same thing. 8 foundries, 8 assemblers. That goes away. Let's move rail down out of the way. Sulfuric acid is a grouping that's configured. That's that. Actually, call that aluminum base 1 because we did some ugly things in there. Downclock freeze and aluminum slice. Yeah, we'll keep that there. Aluminum ingot V2. Hold on. Okay, this was the aluminum ingot in a foundry. Where we had 2 inputs. Whoops. I almost dropped myself in the drink. What recipe was that? So we're using the smelter for this one. Okay, that was the one that had silica. I didn't want to be importing silica into this guy. So this means that the foundry-based one has 2 ingots per 3 scrap. And we're doing 2 ingots per 4 scrap. So we are actually sacrificing a significant output here. We could up our output from 600 to 900, but that would mean we'd have to import silica. And I kind of decided not to do that because the quantities weren't too big. And now that the quantities are big, I'm looking at that thinking, I really still don't want to do it. I have been playing for 2 hours. I've been recording for almost 2 hours. That works out right, huh? So edit. BB smelters goes into configured groupings. Oh, haha. Yeah. I guess I didn't apply changes. Add subcategory. Configured groupings. So in the petroleum base, any of these classify as a configured grouping. That's underclocked refineries for a specific use case. These are all highly tuned inside the petroleum base. Casings and sheets, a specialty. Oh, there's configured groupings. So I just didn't go down far enough. We're going to put these guys at the top, followed by the configured groupings, followed by the rest of this. So apply changes. There. So where were we? We were looking at putting in passive drone ports for our aluminum ingots. We didn't chase down exactly what they were used for, but I think we saw enough to convince us that that's good. So drone stand. We got to use our new blueprint. And since these are passive, I don't have to worry about putting them somewhere where I can get in T to remove the text around the middle of the screen. Yay! So these are going to come out. I am going to priority fill these 2 drone ports, and then it's going to come together here and merge in. So we need a drone. Well, we don't need a drone. We need a drone port. And I'm going to orient it facing outward from the factory. I don't know which direction people are going to be coming to pick up their stuff. Whoosh. This is aluminum ingot supply east. And aluminum ingot supply west. And the power, I keep doing this the same way every time. I keep looking at it the same way every time. And I keep coming up with different places because I don't know why. This time it's on the middle of this one. And on the left-hand side of this one. And you need power at the bottom. How do I want to sneak power in here? From you, I'm going to bring it down to here, and then I'm going to sneak it across to here. Now, I said something about priority splitting over here. I'm just going to do a 50-50 split. And here's your upwards. So I am going to bring you up. I'm actually going to bring you up here. Like that. Splitter. You go to here, and you're going to go over to this guy. At this point, I am not going to be syncing this anymore, so we need to look really quick and see if these guys are all running about 75, no, some of them running 75%. We may or may not be running efficiently. Well, to be proven later. Again, in the long run, if we're sinking all the bauxite into this puppy, we're good. So you need a splitter here, like that. You are coming up here. That. And that gets our first line of stuff coming out. So aluminum ingots. Assembly, yay! Now I know that each one of these is going to be producing output that's going to be real output. And I also know that I need to start acquiring input. And the input is going to require some active stuff. So what I'm thinking is drone ports down the middle to acquire our inputs. We need copper ingots. We need rubber, and we need concrete. Well, actually, I have a list. Copper ingot, concrete, and rubber. So I need 3 drone ports giving us input, and they also have fuel requirements. Here's fuel. So if I bring it up the middle, I can bring it high up the middle, so we have a bus that continues up the middle that will be higher than this pipe. So maybe these 3 levels. There was an extra click in there. There we go. No, that's not right. I heard an extra click. Okay, there's probably a merger that got dropped somewhere. There. So there's our 3 bus lines. So this would be 1, 2, 3, 4, 5, 6, 7, 8. Are we close enough? We are not close enough. We need another stack. Because I didn't put it where I was supposed to put it. There we go. This is giving me real deja vu. I once built a base that had just a huge amount of vertical buses because I was curious as to whether they worked or not. They worked beautifully. So default is here to here, here to here, here to here. And that was even before a number of quality of life changes. Now I can remove the rest of these at some point. Don't need to yet. I think I'm going to keep them in place for documentation of what's going on. This is actually off by 1. Cannot have that. No, it's not. It's perfect. Why did I think it was off by 1? There. So we need 4 more ports in some configuration that allows me to grab fuel from this guy. I'm thinking pole there, and then stack the other 2 on back of them. Oh, we need 3 of them, not 4 of them. And this level here made me think those were too low. So if we need 3 of them, really the third one I'll just put back here. Boom. Okay, power. I'm going to run these toward the middle. So let's just do them all in parallel. And these are going to come to here. So, copper ingots, concrete, and rubber. I would just do them in order. I'm going to face them all the same way. We need to figure out how to get fuel to these guys. So if I can take from here, oh, he isn't providing fuel to himself. That's going to be bad. So he needs to split left and right. We need to come over here. And I need to head back that way and then split 3 ways. And let's just keep this one like it is. So my fuel drone would eventually have run out of fuel, although he runs so rarely. The other thing is this runs through the middle. Ooh. Do I want to just tunnel it through the middle? Do I care? Well, our outputs are going to come out to here and down, so our fuel should be around back. Okay, so we're going to put the fuel like this. And you know what? I'm going to go ahead and clip that partially into the block. So this is going to be a splitter. This guy needs to come from this direction and get split between him and his friends. I will figure out something to do with him, because we do want this to be this way. Oh, I know what I can do. I have now sacrificed the ability to put something useful on there. This guy's going to come through. Do we have walls? We have walls. I can do a load-bearing wall. This guy's going to come through the middle. You are a conveyor wall. You are a conveyor wall. And that's not the right place for the conveyor wall, so we are not a conveyor wall. I absolutely want that there. Screw it. I will just clip through. I am not going to worry about the fuel clipping through that concrete block. I will just assume we've worked out a way of doing that. What happens in the underfloor stays in the underfloor. So from here, this guy needs to have a way to come back to the back, so the easy way for there is for me to put this way and put a splitter coming from that direction. And this conveyor belt's too long. That works. You're going to come over here like that. That doesn't look level to me. Oh, it's level, it's just not straight. So if I hold down the control button, it should constrain it to stay online, like that. Okay, it's straight, but it's not level. These guys are high. Oh. Right, okay. So if I pull it out any further here, it makes it go up, and I don't want it to go up, so I can only come out to this far. All this because my belt was just not quite level by, what, half a meter? Less? Anyway, that's better. I'm going to remove the ceiling mounts. So now I need fuel coming in there. And this is a splitter. And now we need to also send it this way. There. Okay, we have fuel. Let's get the power going. And I'm pretty sure it's just... Was it there? Yeah. And that's the wrong place. Okay. This is rubber for aluminum. This is concrete for aluminum. And this is copper. Copper ingots. We need a drone in each one. Send him to rubber supply. And send him to concrete supply. Copper ingot supply there. So these guys should get their fuel together and should head off and start pulling in stuff. Now, outputs. I'm going to come here and I'm going to go around and I'm going to turn the corner and I'm going to place it on this dead center here. So he will drop down into his place on the bus. We're going to do that with all of them. Which means this guy drops down into the bottom one. And I believe this is off by 1. So mergers here. 1, 2, 3, 4, 5, 6, 7, 8. Make sure this stretches. Yes. Now this guy's going to be coming down from the top to the center. 1, 2, 3, 4, 5, 6, 7. He's going to be coming down right on top of it. Oh, I put it in the wrong place. Reflex, I put things in the center of the foundation. Too long and too steep, would default. Why is this not joining up to that guy? Oh, he's pointing the wrong direction. Ah, damn it. Okay, we do this the stubborn way. Now I take that out because I'm not sure that actually, well, I am pretty sure it actually worked, but I want to make absolutely sure. There we go. I'm going to trim the bottom two off of these guys. It'd be nice to have a pole or something on there. Can I do that? Not a conveyor wall mount, conveyor pole. If I just put a conveyor pole in here, that doesn't look too bad. Don't think I use conveyor poles very often. So we have our outputs coming across in the top three. So we already have our first loads are moving. Yay! Now, if I wanted, I could bring these down to be on the same level so we could have all of them tightly packed, but I don't think that's necessary. So now we are ready to put out the 4 sets of 3 assemblers. 3 assemblers, okay. I have a 5x5 that gives me 8 assemblers, but we're only going to use 3. So we're not going to go whole hog with the 5x5. What I'm going to do is I'm going to go grab my 4x4. If it's still available, I'll grab my 4x4 and center it on these guys. And I'm only going to put in the 1. There and there. And power. Let's see if I go there, there, and there. Should be able to get access to power. Yes. So I'm going to call this the waterfall method of satisfactory design, where you're designing something that's being a bit of a pain and you finally think you've got it worked out, but it's kind of frustrating. So you build it next to a waterfall. So once in a while, you just go watch the waterfall for a bit. And that makes the whole design process so much better. So waterfall wins. Waterfall is the great design methodology. Oh, by the way, that is the only waterfall design methodology that's worth a damn. For those of you ready to go to get all huffy about your other ways of doing software engineering, it's like, no, this isn't about software engineering. This is about satisfactory and maintaining sanity in the face of craziness. So each one of these guys is going to have an output, and I will put the drone, passive drone ports on those corners once we're done. But I'm going to get them done first, so I don't have passive drones hovering over my head while it's doing it. This is actually turning out fairly nice. I don't even mind the big gaping holes where I haven't committed to anything yet. So let us see. Blueprints. I need 3 assemblers. There we go. BB 4x4 3 assemblers. And we're going to place that down 3 times with the white arrow pointed towards us. When we first designed that, it was the pinnacle of dense design. Okay, we need to get power into those. We need to have inputs. They have their 2 inputs, which are reversible, and they have their output here, which can go either way out the front. So that's good. I need to grab power from down below. Easiest way for me to do that is to duck in here and go boop, boop, like that. And it is tempting to go around and completely attach all of them. I don't think I want to do that on camera. I may not even want to do that off camera. Let's get our ingredients. I will trim these stacks later so that things only go as far along the bus as they need to go. Or maybe I'll just leave it for their looks. So we have our 3 drone supplied ingredients at the top, and we have our ingots there. I also will think about whether I want to take the bottom 2 and replace them with a little stand, or just leave them. I kind of like that look. Okay. So first of all, are any of these guys used in any of the other ones? All-clad aluminum sheets are not used anywhere else. Aluminum casings are used in heat exchangers, only a fraction of them. And this guy is going to need steel beams. So the steel beams do need to go on the bus. Now, we put the ingots on the bus. We didn't put the beams on the bus because we haven't done them yet. I completely forgot to do the beams. Fudge knuckles. Can I do them in back? I can do the beams in back here. Even marked them off. I'm smelting the ingots, but I haven't done that one yet. That's what confused me, is I double-clicked on, I Control-C this guy. So most of him goes back to the EIBs. So we'll put the EIBs over in the corner here, and we will arrange for the ingots. To head back here and turn into aluminum beams, which I think are going to go reverse direction on the bus. Well, unless I could feed their output back into here. Of course, it means his output normally would go to here, so this guy would need to wrap tight. We can do that. Oh, that crosses. If I bring his output through here, it means it crosses his inputs. If I bring it through here and back across And back that, yeah, we will work out how to do this. So here we need constructors. Do I have a 4x4 with constructors on it? That would be a nice place to start. That's actually not a bad place. I could just use that one. If I bring it in from the left, that makes it a little more flexible is what I do with my outputs. And it means that in theory, we could get burst production of aluminum beams massive. Okay, yeah, let's do that. These guys won't run a whole lot because the drone port won't be sending out many beams, and we won't be using many back here, but there we go. We need to make aluminum beams, which I apparently have not yet hit the button on. Aluminum beam. We'll need to use another hard drive to get the high-speed connector back when we want it. So just to confirm, we are 3 ingots to 3 beams. And this says 2 of them we're doing 45. That's correct. Okay. Now we still don't have power here because I never did connect this. So the beams are going to go to a passive port here, and they are going to not go. Oh, I better actually plant these because now we are going to be routing around them. There. For now, I don't even need to worry about the drone ports. I just need to make sure I'm not conflicting with these guys. So my output here needs to come back this way. I'm going to bring it. Can I put it inside my own blueprint? There we go. And he's going to need to sneak back in here to this input. So we'll bring him to here. And I'm just going to bring him right across. There we go. So here's our aluminum beams. This actually needs to be on a splitter to go up there. So 5. I'll send him up here. There. Tucked out of the way and providing his output upward. So these guys need to be the encased industrial beam. Okay, so just checking 3 steel beams, 6 concrete to 1 beam. $1836.6. That looks about right. You have power, you'll have your beams. This is your output. Your output is going to go up here. There you go. Now your other input is concrete. So this guy needs to come out this way. I will rerun that more efficiently in a moment. We need splitters up to the concrete level. Okay, now verify we didn't cut these. Those are good. We come down like that. And we route this all once. I think there was a pole here. Yep, there was. So he now has concrete. Let's get these guys going too. Extend our bus. Complete overkill, but for now I want to have the visual look, at least until I decide I'm going to prune it back. These guys' input is aluminum ingots, which is this guy on the bottom, and it's just dead center here, so this is going to be real simple. So splitter, that didn't feel right. Oh, you come from way back there, right. So these ingots are going to get split out to these machines, which are probably able to handle more ingots than we could possibly build. Let's see, what is my absolute maximum here? 22.5. So I could sink 180 ingots per minute. And what is our theoretical output burst? Our theoretical output is, 600, 300? 600 for 2, okay, so yeah, we are not going to be sinking all of the possible ingots forever. But that does mean that our burst output for steel beams is actually quite good from this factory. And you notice that we already have some EIBs coming up. So what else do we get forwarded? Sheets and casings. So casings go into heat exchangers, so I want to do casings and heat exchangers. So let's do heat exchangers first. So casings and rubber. Casings are going to come from there, and they're going to wrap around into our first input. Well, they don't have to wrap around anywhere, they just come out. I believe these will have to be on a splitter, providing its output. Yeah, the merger wasn't dead center, but we'll do that. We are going to bring it up to there. And our other input is rubber. And this is the correct area. So right to here, we want a splitter, right to left. That's in the wrong place. Because I'm insisting on picking up these belts and putting them back down again, this means I end up with a lot of ingredients sitting in my inventory as I do this. Fortunately, the stacks, well, not a lot. I end up some. It can build up if you keep doing it over time. You just got to keep an eye on it. So rubber. So now we need to do aluminum casings. Oh, and his output needs to be routed. Her to her. Again, you're going to come in there. So we are doing all-clad casing, aluminum ingots and copper ingots. So there's our aluminum ingots and there's our copper. Doesn't matter which one's which. Put the splitter out here, facing the correct direction. So we'll do the aluminum there. And the copper is on this. Again, we want a splitter. The input from the top, run it out under our vertical bus. And we go up to the copper level. Some of you will remember doing this kind of a thing without vertical lifts. Yeah. So we now have casings coming out. And the casings are now going to here. And we should have heat sinks. And we have heat sinks coming out. Yay! Almost done. So EIBs are complete. Heat exchangers are done. Casings are done. So just the all-clad aluminum sheet. Which requires aluminum and copper. Well, how about that? Our next door neighbor also required aluminum and copper, so we can just sponge off of his splitters. And our output comes out here. Is that easy or what? Helps if I look the right direction. So we've got aluminum and copper ingots coming off to the first layer here. We have this guy forwarding to this guy on the second layer who's also getting from here. We have this guy pulling in from the third layer to do him. Construction is done. Assembly is done. I can confirm that we have, well, let's be looking at the belt while we do this. So, imports. Yeah, we've got plenty of copper, we've got plenty of concrete, rubber. Steel beam is not something we import, it's something we admit that we're going to be short on. Although, how we're going to be short on it, I don't know. I think what will happen is if everything cranks up with the additional production of steel beams, we will end up keeping these guys sometimes not running. So we may overdraft our total bauxite at some point. That'll be exciting to see. Of course, to see that, I would have to put a sink on every one of these output lines. So now we need 5 passive output ports. I don't think I ran power up to these guys yet, did I? So he's actually coming up in a weird place, but I think I can still make that turn. And no, I can't. But I really want to bring him up there, so we'll just do this the hard way. These guys don't need fuel because they are passive. But I do need to get electricity up to them. I'll worry about that all at once for everybody. I just put him in the wrong place, didn't I? Okay, power. Let's do the undergirding first. I need to bring you guys power down here. I should probably just do this from below. Yeah, much easier. Is that cool or what? I should probably double connect those for redundancy. Careful, you get a visit from the Department of Redundancy Department. And there's no double connects over there. Okay. Go to default so we can put in the single blocks that are taken out. Yeah, I forgot to do this one. Boom. Okay, so everybody has power going upwards, and now I need to connect to the actual thingamajigger. And I am just going to assume that's the right place. Good enough. So do we have green? We have green lights on all of our drone ports, except that one. So I've connected you downward to him. And I think I missed this one. Yes, I did. Okay, so there's my passive and active drone ports. And we should be settling into a nice rhythm, at which point, some point, we will have filled up all of our passive drone ports with their outputs. Can I stand somewhere and get a decent picture of the whole thing? Be up there. How come you don't have power? How come you don't have power? This whole ladder of power coming up here got disconnected. Well, let's just bring you over to here and connect you up. There. Oh, I didn't explode some explodey rocks. I think that's because there were a lot of more explodey rocks here originally, and I exploded them and got what was here. Oh, sometimes these guys don't go away. I think it's because they require to. Yeah, okay. Apparently I got a larger set of rocks there. I exploded some of them and got the power slug or whatever was under there. Okay, up we go. Speaking of blowing things up, remember when there was no way to get rid of these? think I've already gotten this. Yep. Okay, so from our vantage point up here high, we're still too close to see what's going on here. Over there, maybe? Hello.
Harvest the scripture. Compose it into a blood song.
So if I go to photo mode, middle mouse button to hide the UI, and so I can't get a picture of the whole thing. So we're going to ignore the active drone ports over there for a moment. And maybe if I stand on the edge here, I can get rid of my hands. So we are wide angle as we can. And, well, there's our aluminum factory. Let me turn off the editor so we get a good look at this. Yeah, I'll turn off my camera. So that's an aluminum factory. Yeah, my mouse cursor is visible. So just to review, we've got our bauxite coming in here. It's getting mixed with water to be sloppy alumina. And then it's heading over to here to be turned into aluminum scrap. We get 2 lines of aluminum scrap, 600 each, getting smelted into aluminum ingots using pure aluminum ingot. So not the best yield, but good enough. We are stashing some of it in each one of these. Apparently he hasn't filled up yet, and he has. We are then assembling it into, let's see, get these in the correct order so I can see. Encased industrial beam is in the far upper left because it requires the next step. These two, heat sink is hidden behind the drone port. It looks just like these. It's doing heat sinks, heat exchangers. The heat exchangers use aluminum casing, which is from here. Again, looks just like that guy. And here we're doing our all-clad aluminum sheets. And finally, down on the end, we have our constructors, where we are way, way overbuilding aluminum beams. And I have saved a picture of that. Not sure why he opens and closes. So there we go. There's a nice view of the factory. That's a better view actually than what I had a moment ago. And I will call the recording at this point, and we will come back to whatever our next thing to build is. I'm not sure what our next thing is. It's probably going to be pretty big. I've been kind of focused on the aluminum factory and getting all the other little teeny factories together so that I could build this, which is why I kind of coughed out those as shorter, without voiceover, just kind of plop down something and build something that, like bring in plastic and rubber. Anyway, I'm going to see you in the next one.